Hello, everybody. Welcome back. So today we will talk about how to exponentiate a matrix. Oh, sounds really cool, right? In this video series, I hope that you can see how linear algebra and differential equation intersect, and you can review most of the important concept of linear algebra in one series. And so that's being said, let's go ahead and start to it. So let me go ahead and write something. So what is our goal of our video today? So let me write. So this is our goal. So our goal is to compute the exponentiate or e to the power of a matrix. Okay, so just want to make sure A is a matrix. Okay, so how do we do that? Right? It's so weird. So in the past, you guys probably get used to e to power of 2. So for example, like e to power of 2 is e times e, right? E in this case is the exponential number. E to the power of 3, for example, is e times e times e. E to the power 1/2 is square root of e. What about e to the power of a matrix, say 2, 3, 5, 17, right? So how do you compute this? Well, there's a brilliant mathematician. His name is Taylor. And according to Taylor series, we will use that. And we can use the beautiful characteristic of the series to compute. So let me go ahead and write down. So what did Taylor series say? So according to Taylor series, so if you recall, e to the power of x in this case is number, is the summation of k equals 0 to 50 of x to the power of k over k factorial. Okay, so what this term means is it means x to the power 0 over 0 power plus x to the power 1 over 1 factorial plus all the way to x powered 50 over 50 factorial. Okay, that's one of the decent way to visualize it. So matrix built on the same motivation. So matrix exponentiation is built on the same motivation. So what does it mean? It means that we can say that e to power matrix is the summation of k equals 0 to the 50 of a matrix to power k over k factorial. Okay, this is that one right here. Now, the reason why you guys see that we use the power of Taylor series to compute e to the power of a, because we can compute e to the power a to the power square, a to the power 2, and a to the power 3. We can do that. Like for example, we can do 1, 2, 4, 7 to the power 2. We can definitely do that. And then we can sum it up and we can grade our exponential. So this is a very interesting and yet intriguing topics. It's a brilliant way because normally you cannot do that, right? Normally this is a matrix. It's not like e to the power 2, e times e. But we can use the properties of Taylor series, which is a sum of power, right? And with that, we can regrade e to the power of a. Okay, very, very nice. So what is the next step? A is a pure matrix, right? We need to decompose A. or in other words. So next step. All right. Next step, we need to smartly decompose A. A is a matrix, okay? Or in other word, we need to find a nice expression for A. What do I mean by nice expression? Nice expression means that, you know, A, you can treat you can decompose A as a matrix to a multiplication of matrix in a way that when you power it to power of k, like A to the power of k, A to the power of 2, A to the power of 3, you get a very nice pattern. You get a very, very nice, and things cancel out. Okay, so how do we do that? Well, a lot of amazing mathematicians, they had researched these topics for years, and they have come up with a very, very beautiful proposal. Okay, which type of matrix will lead to on the cancel out, will lead to on the beautiful pattern? Diagonal matrix. Okay, so this is the proposal. Okay, this is also a very good movie by Ryan Gosling, I think. If you have time, please check it out. It's great. So what is the proposal? The proposal is I can turn matrix A to a matrix P times a diagonal matrix times the P inverse, or P to the power of -1. Okay, so why is this the case? Okay, let me highlight this. So let me make some definition for you. So D is the diagonal matrix. Okay, and P is a random matrix. We will find way to compute. Okay, the reason why is this the case is why do you want matrix A to be a random matrix times the diagonal matrix? And D is not diagonal matrix. Let me make some color. It's not incorrect. It's not enough information. So D is the diagonal matrix of eigenvalues. Okay. I will mention the terms again later as we go down the video. But yeah. So why do we do this? What's the motivation? What's the story behind this? The reason why we do this, we turn A into this junk because so instead of A to power of k power, you can do P to -1 to the power of -1 to the power of k, and it is very nice, very, very nice. It has a lot of nice pattern. Things cancel out, okay, as we will see later. Okay, so with that being said, I will stop the video here as part 1. So in conclusion, the main point of part 1 is to talk about 2 things. The first thing is we're going to use Taylor series to compute the exponential of a matrix, and the second main idea is that main matrix A is going to be decomposed into multiplication of a random matrix P, diagonal matrix of the eigenvalues, and that random matrix invert, and we'll find way to compute P and D later. Okay, thank you y'all for your attention, and I'll see you in the next video. Bye bye.